Google to learn how to search. I'm talking about a research-backed development from Alibaba that could dramatically reshape how large language models are trained. The project is called Zero Search, and it allows AI to simulate its own search engine, bypassing Google Bing or any commercial API altogether. Why does that matter? Because right now, training AI models to retrieve information is expensive, slow, and dependent on tech giants. But with this new framework, Alibaba claims to cut costs by nearly 88%, while even outperforming traditional search engines in certain tasks. Let's break this down: how Zero Search works, why it matters, and what it means for the future of AI. The problem: training. The hidden cost of teaching AI to search. To understand the significance of zero, you first need to understand the problem. It's solving modern AI systems. Especially virtual assistants, RAG models, and AI agents often need access to real-time or up-to-date information. The way most developers solve this is by connecting their models to web search APIs like Google Search, Bing API, or SIR API. These services return documents based on a user query, which the model can then read, summarize, or use to answer questions. But here's the problem: that access isn't free. In reinforcement learning setups, AI models don't make one or two queries, they make tens or even hundreds of thousands of them, while learning how to retrieve relevant results. According to Alibaba's researchers, processing 64,000 search queries using SIR API tied to Google Search would cost around $586.70 at scale. That becomes a serious cost, especially for startups or academic teams without enterprise-level budgets. And it's not just about the money. Search engines don't always return consistent or high-quality information. A model might get a blog post in one query and a Wikipedia snippet the next. That variation can make the training process noisy and unpredictable. Developers are essentially outsourcing part of their training data pipeline to a third party, and that means less control over what the model actually learns. Zero Search offers an alternative. How Zero Search works. Zero Search without search engines. Zero Search is a reinforcement learning framework developed by Alibaba Group researchers. Its core idea is to remove the dependency on real search engines during the training phase by simulating search results internally using a large language model. Here's how it works. First, the team takes a pre-trained language model and fine-tunes it through supervised learning to act as a simulated search engine. This LLM becomes capable of generating synthetic documents in response to a query. Some relevant, some irrelevant. Essentially, it learns to mimic what a real search engine might return. Then comes the reinforcement learning stage. Instead of retrieving real web pages, the model interacts with this simulated environment. It's trained using a technique called curriculum-based rollout, where the quality of simulated documents is gradually degraded. This teaches the AI to distinguish signal from noise, relying on relevance, not just surface-level keywords. A key insight from the researchers is that LLMs already possess extensive world knowledge from pre-training. This allows them to generate content that's thematically and factually close to what a real search engine might produce, according to the paper. The primary difference between a real search engine and a simulation LLM lies in the textual style of the returned content. This approach also removes real-time API call constraints, making the training loop faster and cheaper. Performance results. Performance results that surprised everyone. Alibaba didn't just propose this framework, they tested it extensively. Zero Search was evaluated across 7 different question-answering datasets, covering a mix of open domain and domain-specific benchmarks. These tests aim to assess whether simulated search could truly compete with or even surpass traditional training methods that rely on real-time access to search engines. The results were notable. A 7 billion parameter model trained using Zero Search achieved comparable performance to models that had been trained using actual Google search data. This showed that simulated search could match real-world performance under standard evaluation conditions. Even more impressive, a 14 billion parameter model trained entirely through Zero Search not only matched but in many cases outperformed the baseline models that had used real search engines for reinforcement learning. This result points to the strength of the simulation strategy and the underlying language model's ability to generate highly relevant synthetic documents. The cost savings added another layer of impact. According to Alibaba's analysis, training with Google Search via SIR API for just 64,000 queries would cost approximately $586.70. In contrast, using the 14 billion parameter model simulated model on 4 A100 GPUs cost only $70.80. That's a direct 88% reduction in training cost without sacrificing, and in some cases, even improving model performance. The benchmark datasets used in testing included natural questions, hotpot QA, and trivia QA, all of which are widely recognized in the research community for evaluating retrieval-based QA systems. Importantly, the models were not fine-tuned to the test sets, and all evaluations adhered to standard open-source practices. The team also made the entire training pipeline evaluation protocol and supporting code publicly available, further reinforcing the transparency and credibility of the findings overall. These outcomes suggest that AI systems can now learn how to search without ever connecting to a real search engine, at least during the training process. It's a shift in methodology that could significantly influence how future retrieval models are developed. What this means for AI developers and startups: the implications of zero search extend beyond cost reduction for developers building AI tools that rely on information retrieval, whether for customer support bots, virtual research assistants, or retrieval augmented generation. RAG systems training is one of the biggest bottlenecks. One of the most notable advantages of zero search is that it makes high-performance retrieval models more accessible to teams that don't have access to the scale or resources of a major tech company by eliminating the need for API calls or maintaining a private search index. Developers can train and fine-tune their models in a fully controlled, contained environment. The framework has also been tested on multiple model architectures. It works not just with Alibaba's own Qwen 2.5 models, but also with widely used open-source families like Meta's Llama 3.2. It supports both base models and instruction-tuned variants, which means it can be adapted to different training objectives and downstream tasks to promote research transparency and reproducibility. The team released the code-based training data sets and pre-trained models on GitHub and Hugging Face. This move opens up zero search to the broader AI community, encouraging experimentation, adaptation, and integration into other workflows. Developers now have the option to simulate a search environment that they can fully define and control, removing the unpredictable variable of third-party search APIs, and that alone is a significant shift in how AI models are trained and evaluated. Redefining the future of search. Future of search and AI training. Zero search also raises a broader question. If language models can simulate the act of searching accurately and at scale, do they still need to rely on external search engines in the long run? This doesn't mean search engines are obsolete, but it does suggest a shift in how AI systems retrieve and learn from information. Instead of being dependent on external tools to provide knowledge, models can simulate the retrieval process themselves, using their internal knowledge and controlled training pipelines. This simulation-first approach could become a blueprint for self-sufficient training loops where models generate, retrieve, and evaluate their own data with minimal external input. That might sound abstract now, but the building blocks are already visible in projects like OpenAI's AutoGPT, Google, DeepMind's Gemini, and Alibaba's Zero Search. It's also worth noting that Zero Search isn't the first attempt to reduce reliance on traditional search engines. Researchers at Meta AI, Anthropic, and Cohere have been exploring in-context learning and synthetic data generation to improve model retrieval and reasoning. But Zero Search stands out because it ties those ideas directly into a reinforcement learning framework and backs it up with measurable results and cost benchmarks. This technique gives researchers full control over what data the model sees, how it sees it, and what kind of feedback it receives. That level of transparency is often missing when working with black box APIs or proprietary search infrastructures. Risks. Limitations and areas of caution. While Zero Search offers clear advantages, it's not without trade-offs. One limitation is that simulated documents are only as good as the pre-training of the model that generates them. If the base LLM lacks coverage in a particular domain, say biomedicine or law, it may struggle to simulate accurate search results for those fields. There's also the issue of style realism. Even if a document contains relevant facts, its tone or structure might not mimic real-world sources like news articles, academic papers, or forum posts. That can create a gap between training and deployment environments. Another area to watch is bias propagation, since the same model is generating both the queries and the search results. There's a risk of feedback loops where the model reinforces its own assumptions. In contrast, using external sources introduces more stylistic and ideological variation, whether for better or worse. Moreover, Zero Search is not a live search tool. It's designed for training, not real-time retrieval in production environments where up-to-the-minute information is necessary, like news aggregation or stock market analysis. External search access is still essential. The authors also acknowledge that while simulated search works well for many common knowledge domains, it's not yet a drop-in replacement for real-world high-fidelity search. In all contexts, the goal isn't to eliminate search engines entirely, but to give developers the option to avoid them during training when appropriate. A shift in AI's foundation Zero Search reflects a growing trend in AI toward building self-contained training systems that reduce dependence on external tools. Similar approaches include synthetic data generation self-play environments like AlphaZero and closed-loop agents such as AutoGPT and Cicero. These methods all emphasize data simulation over data collection training models to improve using what they already know. Zero Search fits this direction by enabling models to simulate search behavior internally without relying on external APIs. This shift has economic and developmental implications, potentially lowering costs and expanding access to advanced training methods. The full Zero Search framework, including code and documentation, is available on Archive GitHub, and Hugging Face at its core, the breakthrough shows that AI can now learn retrieval not by searching the internet, but by generating its own search environment, reshaping where intelligence is developed in AI systems. If you've made it this far, let us know what you think in the comment section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.